Hello, my name is Jacob Buell. This is Lab 3 about black hole for the class of Physics 2211. Now, for an introduction to this lab experiment. The aim of this lab experiment is to determine the mass of a black hole by analyzing the motion of a star. And more specifically, this is the first part of the lab. And then I will use the mass of the black hole that we found by calculating the net force on the star to find the initial velocity of the spaceship to get the spaceship close enough to the black hole where it's able to leave the system without crashing. Now, some background knowledge is needed, and these are the effects of Newton's laws and momentum. So, Newton's second law. His second law of motion states that the net force is the change in momentum over time. This law could be written as F net equals ma, or also F net equals dp over dt, which is the change in momentum over time. Now we also need to understand the gravitational force, which the gravitational force is a function of the distance of two bodies and their mass multiplied by a gravitational constant. And it can be written as F of gravity equals the gravitational constant multiplied by the mass of the two bodies times the or over the distance squared between them. And the gravitational constant is the 6.67 times 10 to the power of negative 11. Now, Newton's second law of motion, it can also be broken up into parallel and perpendicular force components, and this will allow it to be easier to calculate. So F net perpendicular equals mv squared over r times the n hat direction, which is the perpendicular direction. Now F net parallel is just equal to dp over dt, just in the parallel direction, so in the direction of the momentum or velocity. Now, for the system and surroundings in this lab. This is a completely code experiment lab, and so the system in this code experiment is the star, as we'll be calculating the net force on the star. And this is for the first part of the lab, to get the mass of the black hole. Now, the surroundings are the black hole and everything else. So, in this lab, I created a specific star trajectory using my school email, created a glow script model using in Python to track the Fnet on the star, and we use this to get the mass of the black hole. Now, using the mass of the black hole, I can calculate, in the second part of the lab, the initial velocity needed for the spaceship to leave the orbit of the black hole. This is important. It needs to be able to be fast enough to have enough escape velocity to leave the orbit, but also not crash into the black hole or crash into the planet that it's taken off from. Now, so part one of this experiment was trying to get the mass of the black hole. And so in this, you can see Fnet 7.5 times 10 to the power 28. Fnet parallel is 2.8 times 10 to the power 28. Fnet perpendicular is 6.9 times 10 to the power 28. And the mass of the black hole, which is the important part that we're trying to figure out, is 6.43 times 10 to the power 33. So really, really a lot of mass. Now, one of the inputs to this system was the mass of the star, which we knew beforehand. And that was 2 times 10 to the power of 28. Now, so part 2 of the lab experiment, we have the mass that we know. So we input that as, or one of the inputs in the closed script code. So you can see on the top right in the little photo. We also have other constants, just such as the gravitational constant, the mass of the two planets, or the planet and the ship, and the rate of change of time. So you can see in the graph, purple is the spaceship and blue is the planet. So it takes off from the planet using an initial velocity that was calculated. So it goes fast enough to leave the planet and not crash into the planet and not get sucked into the black hole. So it has enough escape velocity to keep going. Now, what does it mean? The net force and its parallel and perpendicular components are the same mathematically, but the change in momentum is easier to calculate. Now, what if you're trying to get the spaceship to orbit the black hole? So the initial velocity of the spaceship to orbit the black hole would have to be a smaller initial velocity. This is because instead of leaving the orbit, we would need the gravitational force to retain the spaceship in its orbit. And to do that, the spaceship has to be going slower than the orbit's escape velocity.